Hi, I'm Minja. I'm going to be presenting the paper, The Participatory Design of a Robotic Mental Wellbeing Coach. My co-authors are Indu, Bodala, and Hatice. I'm from the Affective Intelligence and Robotics Lab from the University of Cambridge. A bit of background first. I want to introduce some concepts before we go into the research itself. So, social robots for mental well-being. The goal of why we would want a social robot to improve or maintain the well-being, the mental well-being of humans, is because sometimes human coaches aren't available due to financial issues or accessibility issues. And they could intervene before the mental well-being issues are exacerbated. Previous studies have focused, for example, on weight loss. So the Autumn robot was helping instill behavioral changes in people while they were dieting, and the Jibo robotic platform was used to deliver positive psychology interventions to students. The well-being practices we're focusing on in this paper are solution-focused practice, mindfulness/meditation, and life coaching. Solution-focused practice focuses on looking for resources and working toward preferred futures together with a coach. Mindfulness and meditation focuses on bringing awareness to daily activities as well as slowing down and meditating. And life coaching focuses on identifying concrete goals to work together toward with the coach, and it can use techniques such as visualization, writing, drawing, or body awareness exercises. The participatory design of a robotic mental well-being coach is the main structure of this paper. So participatory design means including the perspectives of relevant stakeholders in the design process and involving these people as active designers as well. With participatory design, we aim toward acceptance and long-term adherence to the robotic mental well-being coach. There are some previous studies of participatory design in human-robot interaction for well-being, namely designing a sign language robot for children with autism, a dementia caregiving robot, as well as a robot for older adults with depression. So we conducted a user study and we did data gathering through participatory design. So we interviewed prospective users, of whom there were 8, as well as well-being coaches, of whom there were 3. And these coaches were all specified in a different practice. So solution-focused practice, mindfulness/meditation, and life coaching. And together with the interviews, we also conducted some focus group discussions. And these were held with the prospective users, with 4 users each per group. And as a result of this, we got some very rich qualitative data that we present and analyze in the paper. And here in the image, you can see an example of gathering data during the focus group. So participants were asked to vote on which robot they thought would be most appropriate for a robotic well-being coach. And the ones who voted 1 was the most popular robot and 5 was the least popular robot. And they all had their own color. So here you can get some idea that the results were quite varied. We also used post-it notes. So we conducted a preliminary thematic analysis on the interview data that we gathered, got some themes, and placed these onto the Miro board, which is an online design service. And the participants could then vote on which things they thought were important. So we did this for a variety of questions. Here, people are voting on what things the robot should be able to conduct to help them. So results and discussion. The results of the thematic analysis. So we analyzed transcripts from both the interviews conducted with both coaches and prospective users, as well as the focus group discussions, which included the prospective users. And we conducted a thematic analysis of the data according to Brown and Clark. And we found major themes in the data, 9 themes altogether, which are presented with quotes in the paper. Here you can see the themes. The size of the theme corresponds to how prevalent it was in the data. and surrounding the major themes, which you can see in orange, are smaller sub-themes, which you can see in blue. And so robot capabilities was the main outcome of this paper, which we do discuss in detail. The results you can see here. So we found quite detailed information on desired robot capabilities. There was a lot of data on that. Interestingly, robot form preferences were very varied. So some participants would have preferred a humanoid robot, since they found that a robotic coach should imitate a human coach as much as possible. And others preferred a more abstract robot and explicitly stated that they would not like a robotic coach to try and imitate a human. Rather, they would prefer the robot to resemble something else altogether that does not already exist in the world and does not already have a purpose. However, what was consistent, all participants that commented on the topic thought that robot function should match robot form. So if the robot were to be a humanoid, it should act in a way that a human normally acts. And if it were to be abstract, it should use other forms of communication rather than speech and things that humans usually use. So as an example, I have some quotes here. So one participant, for example, said that their expectation would be gauged based on how it looked, and if it looked like a human, I would expect it to act or instruct me like a human. Then another participant said that the less resemblance to a human, it's better. But then another coach said that, referring to the robot dog Miro, it's cute, and with a robot dog-like features, it would be nice to pet, but it would be weird hearing a dog talk. So in a way, they're all saying that the robot's function should match its form, as illustrated by these quotes. Some of the other results we found were that participants were receptive to scientific evidence and more open to using a robot for well-being coaching after being presented with evidence. So at the end of the group discussions, we showed prospective users some previous studies where robots had been useful for helping with well-being. So for example, the two studies I referred to earlier, where the Jeeper robot was conducting positive psychology and the Autumn robot was helping people with weight loss. And after being shown this research, participants said that actually, even if I was a bit more apprehensive before, now that I've seen these results, I'm more open to trying the robot. Coaches were also quite open to evidence, and they were also confident that the robot could perform some well-being practices. So they said that some of the more simple well-being practices that are easier to script, they felt that a robot could well perform, since a lot of well-being practices are already being realized in mobile apps. And one coach in particular said that a robot may be more helpful than a mobile app because a robot could give a person the sense that someone is there for you, that someone is being present during the well-being coaching interaction. In the discussion, we detail how prospective users and coaches are open to the idea of a robotic coach and how our rich data will inform the direction of future design. And in future research, we aim to formalize design guidelines and recommendations for a robotic well-being coach. And we hope to conduct more of this research in the future. Thank you so much. Here you can see my co-authors, and I hope you enjoyed this presentation.